first thing that we're going to do under this section is take a look at the read table method. So we're going to run the line where it has the question mark and then read.table. So there are a few different ways that we can read in various forms of tabular data. The most generic of those is read.table. And then we just have these different, we'll call them convenience wrappers, that wrap around read.table and they just call it with specific default arguments. So read CSV is going to give us a default for the separator or the delimiter of the comma, which as we would expect for comma separated, and then a default of the period for our decimal value. Read CSV2 is more of, I believe, a European version of this. In certain locales, they use a comma for a decimal, and in that case, we need a different separator, and so that's going to be the semicolon in this case. And then read delim, by default, this one is for tab-separated values, and then we have, of course, the decimal, and read delim2 is just the analog of CSV2, but for the tab-separated. So again, we have a comma for the decimals. Alright, so again, just to recap, read table is the most generic, and each of these just have very specific default values. Whereas read table, its default separator is any white space. Okay, so moving on, one of the first things that you're going to want to do is run the getwd, which is going to print out your current working directory, and then also setwd. There are a number of files that are included with this tutorial. If you want to follow along, then you'll want to set the current working directory to wherever you've placed those files. So for example, it may be something like home, whatever your username is, slash, up to wherever you have these files located. And I'll just undo there. Okay, so once you have that setted, we can read in these different files. First one that we're going to load using read CSV is attenuation.csv. This is a data set that's included with the R datasets, the built-in datasets. This is just to illustrate how we can import these from our local machine using read CSV. So we're going to load that in, and it's now having the variable name of ATN. And let's go ahead and print out the head of that, and we can see the top 6 rows of this particular data set and the column names right here. And just to be sure, let's run class ATN, and we can see that it's a data frame. And one thing we can also do with read CSV is we can tell it that there's no header. So for example, we have another file here called attenuation nocalls.csv. This one has no column names, so it starts off right away with just the data. If we were to run this without, if we were to run read CSV without setting header to false, then the first data records would be set as the column names. Another option we have is to tell it how many rows to read in. So at most, it's going to read in 10 rows, in this case, since we set n rows to 10. And we haven't assigned this call to any particular variable, so this is just going to print out the first 10 rows of our data set called attenuation nocalls. And we can see that the default column names are just capital V with a particular number for the column number, so V1 through V5 in this case. However, what we can do is we can set these column names ourselves. So in this case, we have our ATN data frame that we've already loaded that has column names. So we're going to create this variable called calls, and that's just going to be a vector that holds our column names for us that we're going to get from that initial data frame we read in. And then after the semicolon, we're just going to print out what those column names are. So we can see in this vector of column names, we have event, mag, station, dist, and excel. And now we're going to read this in again, our attenuation no calls, same thing, header false, 10 rows, but this time we're going to assign the column names. So call.names equals our vector of columns, of column names. So we'll run that, and we can see now that they've been appropriately applied. Aside from assigning column names, what we can do is also apply particular classes for our columns. So in this case, we're going to create a vector called classes, and in this, it's just going to be one simple vector that has the data types for each column. So In this case, we have 5 columns, and we're going to assign 5 different data types. So we have character, numeric, numeric. And I've somewhat arbitrarily chosen these only to the extent that they will work as far as what data is in there. For example, if I were to call numeric on something that had characters in it, alphabetic characters, then this wouldn't work. But otherwise it is a little bit different from the original. So let's create that vector. In fact, actually first I'm going to clear our console again. So let's go ahead and create that, and then this time we're going to read our attenuation.csv. So this is the one that does have the column names. We're going to assign it to X so that we still have the ATN data frame. So in read CSV, we have this argument called call classes, and we'll set that equal to our variable. All right, so now what we can do is we can check these different data types. In order to do that, we're going to use this sapply method. And I believe we have seen this in an earlier tutorial. Essentially what this is going to do is it's going to loop over this object, and it's going to apply this particular method or function to it. So for sapply, and we're going to get all of our column names along with whatever its data type is. So for X, we have these data types right here, and we're going to do the same thing for ATN. And we can see that instead of character, we actually have integer in the original, and then double, and integer is now character, double is double still for both of these. So you'll notice that I just passed numeric. That was just general, but it is, more specifically, it is of type double. Okay, so now we can also create a data frame by reading text directly from memory. This does happen occasionally, and where you may have some comma-separated values or something like that, and then also the new line characters, the escape characters that is, that separate the rows, as opposed to actually having a text file. This may happen when you read in from particular APIs or websites for scraping. So what we're going to do is we're going to create a very simple data string, and so it just has the variable name data.string. And this is our string right here. So we have our columns, call 1, 2, and 3, that are comma separated, and then we have our new line character right here for separating our different rows. So first row is just 1, 2, 3, second row is 4, 5, 6. So let's go ahead and create that data string, and let's actually go ahead and take a look. Let's just output that just for fun. So there's our data string. And now what we can do is use our read CSV method, but instead of passing it the default path argument that we often use, we're going to say text equal whatever it is that our string is. So data equal read CSV, text equal data string. And then we'll just print out our data, and we can see that comes out nice and neat. And again, we'll do class and data, and we have data frame. All right, so we're good there. In this section, we're going to be looking at a couple different methods for working with raw, relatively unstructured text. It may be semi-structured, but isn't quite readily usable yet. So, for example, it may somewhat resemble JSON, but isn't quite actually in the JSON format. And we have a couple different methods for reading in this raw text. The first one is readcar. This one allows us to get one complete string from a file, although it does have the downside of having to set the maximum number of characters to read in. And if you don't know the total number of characters in a particular file, I recommend just setting this to some large value that you know is going to be larger than the number of characters in that set. Overall, the usefulness for this particular method is just for reading in samples from text. I don't recommend it as your primary use for getting the raw text. So we're going to run raw string, or we're going to set raw string and equal to, we're going to read in this raw text.txt. This is another file that should be included with this tutorial. We're going to set the maximum number of characters to 1000. So we'll run that, and we can print this out, and it's extremely exciting. So this whole string says some random text that contains hashtags or other blah blah blah, and then we also have some debug line that maybe came from a particular log. So perhaps this is a log file, whatever. Pretend it is whatever you want it to be. And what we can do is actually notice in here that when it reads this in, we have some escape characters that represent new lines. And if we use this cat method that comes with R, and we're going to so essentially just wrap that around our raw string, we actually get this nice printout that essentially pays attention to these escape characters. Whereas if we were to run something like print on our raw string, then you'd notice that we actually just get the raw string again. If you're used to Python, then that may be a bit frustrating. Python is essentially going to be doing the same thing as cat here, so it would print out all of our lines formatted based on these escape characters. So that's what we want the cat method for. So in this case, we can see here that we have these different lines. So we have some random information at the top of the file, and then it moves on to some log data. We have a debug line and a warning, and it looks like I broke it. Okay, so method number 2, we can use read lines. This one we're going to run on the same file, raw text, and what we'll notice is that with raw lines, let's see, incomplete line found. Okay, so this warning message, you can ignore that. With read lines, it looks for, by the way, we have this comment here, expected warning prints. It looks for particular end of line indicators or end of file indicators, but what we can do is just pass in the argument warn equal f, or we could also type the full false. By the way, by default in R, a capital F is a shortcut for false. So if you ever set capital F equal to some other value, then you'd no longer be able to use that shortcut unless you removed that attribute from your global environment. All right, so we'll read this once more and notice that we do not get the warning. All right, so great, just set warn equal to false if you know that this isn't formatted text, and you won't have that issue. Now let's go ahead and print this out, and we can see that this file is now somewhat in the form of a vector, and we have these different values. So we have each of these lines, everywhere that we had this escape character for a new line, each of these comes out as a new line on its own. So we have this empty line here that corresponds to, or empty string that corresponds to this empty line up here. Okay, so read lines is going to separate all of these, and we can get the same printout effect using cat using setting the separator. So we're going to say sep equal this \n, and that will print it out just the same as it did before. Whereas otherwise, let's go ahead and do this manually. Let's say cat, and we're going to do raw.lines. Run that. And we can see that what we have here is these escape characters for our new lines are actually now gone. It did not have the sep by default set to that particular new line escape character. And another thing that we can do with read lines is to set the number of lines to read in. So in this case, we're only going to read the first 2, just so we can see essentially the head of our file. So we have some random text, and then our second line values 123,000. Overall, it's pretty simple to read in all of this raw text, and then you can work with this how you like based on how you chose to read it in. So with read lines, we have each of the lines in the document separated as individual strings, whereas with the read car, we're going to get one complete string. And so again, if you wanted to access, say, read lines, just treat this like any other vector in R. So we'll do read lines 2, and I accidentally did read lines. We don't want that. Raw lines. Sorry, guys. So raw lines 2, and we can get that second string there. So this may be very convenient, and you could always use paste to put all of these together back into one complete string if you liked. Okay.